Hello everyone, myself Dikshit Hegde. I am glad to present our work DAAE, that is Disparity-Alleviation Autoencoder, towards categorization of heritage images for aggrandized 3D reconstruction. This work is carried out with Tejas Anvekar, Ramesh Shuktavi, and Uma Mudingodi at Center of Excellence in Visual Intelligence, Kelly Technological University, Hubli, India. Due to natural calamities, there is degradation of heritage sites. There is need for the digitization of heritage sites. Through digitization, we can preserve the heritage sites for future generation. We can also further create a walkthrough of AR and VR. We can generate 3D models of heritage sites using single view or multi view images, LiDARs, scanners. But scanners and LiDARs use pre-processing steps. Collection of images of heritage sites across the globe is time consuming. Towards this, we perform the collection of images through crowd and name that the data has crowdsourced data. The data is unstructured and unlabeled, resulting in poor and merged 3D models as shown here. A minimal similarity between structures will create a merged 3D models. There is need for the categorization of these images, as there is no associative labels for the crowdsourced data. Unsupervised categorization, that is clustering, is one of the technique. Categorization of high dimensional data is computationally expensive and time consuming. Clustering needs lower dimensional features, which is disentangled and have complete information from the image space. Dimensionality reduction methods like PCA, kernel based PCA, etc., extract features from images which might not be suitable for categorization. Extracting relevant features with deep learning based methods is current trend. For deep clustering, recent work uses autoencoder which computes loss in image manifold space. Ali et al., that's DAC, in et al., that is IDC, computes loss in latent and image manifold space individually, but there is lack of information validation from image space to latent space. Towards this, we propose disparity elevation autoencoder, that is DAAE. In DA autoencoder, we have a DA encoder where we tap intermediate representation of the data and the latent space. Towards optimization of the DA encoder, we model reconstruction loss consisting of MSC loss function and structural dissimilarity loss, where structural dissimilarity loss consists of 1 minus structural similarity of the input image and reconstructed image. We perform 3-point approximation for inducing a contractive and discriminative optimization through theory of indiscriminables. Towards this, let us consider a pair of images I, j projected in image space xi and xj. When propagated to DA encoder, we get intermediate space or neural representation space of the images AI and AJ respectively, and latent representation ZI and ZJ. 3-point approximation results in copying the constraints from image space to latent space. Towards this, we introduce Jacobian of neural representation and latent representation for inducing nonlinear independent component analysis. We estimate the distance between the pair of images in their respective space, and we minimize the distance using the model loss function as shown here. Here, the distance metric can be a MSC or MA function. We demonstrate the effect of proposed model on latent space representation. We can see that there is overlapping clusters in AE, but similar classes are disentangled in DAE latent space in both MNIST dataset and IDS10 dataset. We also compare clustering accuracy of our result of a proposed model with state-of-the-art method. In MNIST dataset, there is an increase of 10% accuracy, For fashion image dataset, there is approximately 4% increase. In USPSC dataset, there is approximately 5% increase. And for IDH, there is 18% increase than the state-of-the-art models. By applying IDC as a plugin to DA encoder, we compare the results with the model using clustering loss as an order. In fashion image dataset, there is an increase in 9% accuracy from the SOTA method. We present the effect of DA encoder on heritage sites before and after categorization through 3D reconstruction. We presented DAE, that is Disparity-Alleviation Autoencoder, towards categorization of images for better 3D reconstruction. A modified version of autoencoder which is robust and interpretable. It captures disentangled the features of images using disparity elevation loss function. Thank you. For more information, contact us at savvy@caretech.ac.in.